-3 plus 8, 5 is equal to 5. So that checks for that equation. Now let's check the second equation. So we're going to put in 5 for y is 4 times 3 minus 7. 5 equals 12 minus 7. 5, in fact, does equal 5. So the solution point does work for both equations. So the solution to this problem is 3, 5. The second problem, we've got our equations in standard form. When the equation's in standard form, we probably want to use x and y intercepts. You can move it into slope-intercept form, but I'm going to use x and y intercepts. So if I set my y equal to 0 to find x, I get rid of the y, x equals 2. If I set my x equal to 0 to find y, y is also 2. So on my graph, I'm going to put a point at x is 2 on the x-intercept and y is 2 on the y-intercept. And if I look, I can see that the pattern is a box of 2 by 2. So if I continue that pattern on my graph, I can now create that line. You want a nice accurate line so you can find the intersection point. And I'll make that line blue as well. And now if I do my other coordinate, if I set y equal to 0, 3x equals -3, x would equal -1. And if I set x equal to 0, 3y equals -3, y would equal -1. So now I put the point at -1, -1. Okay, and I'm going to see that that makes one little box, so we're going to continue putting a point at the corner of every box and draw that line, and we'll make that line yellow. Now if I look at these two lines, what do I notice? I notice that they are parallel. They will never intersect. So my solution to this set is no solution. Make sure you put that clearly on your paper somewhere. Okay, so continuing on. Example C. We again have slope, we have these are in standard form, so we're going to graph from standard form. So let's start with the x. If we set y equal to 0, 2x equals -3, x would be -3 over 2. If we set x equal to 0, -y equals -3, y would equal +3. So on the y, we have a point at +3. On the x, we have a point at -1.5. And if we continue, you see it goes up 3 and over 1.5. If we go up 3 and over 1.5, up 3 and over 1.5, and we could go down and do the same thing. We have our line. And if we set the second one and do the same thing, if we cover up the y and make y 0, 8x equals -12 would be -12 over 8, or -3 over 2 reduced. And if we do the y, -12 divided by -4 would be +3. If I make the first equation blue, this is my line. What I notice with the second equation, I have the same x and y intercepts. So when I go to graph this line, it's going to make the same line. When they're the same line, that means they share all points. There's an infinite amount of solutions. So we put infinite solutions, and we have our answer. One more. The first equation for this one is in slope-intercept form. So again, I'm going to identify my slope. It's -1 over 1, and my y-intercept is 1. So I'm going to begin at the 1 on the y-axis, and I'm going to go down 1 and over 1. So we have a set of points. We connect our points with a nice straight line, and that's going to be my first equation. The second equation is in it's standard form. So again, we're going to cover up the y to make y 0, and x would be 3. And then we're going to cover up the x to make y 0, and y is -3. So we're going to go to 3 on the x and -3 on the y, and we're going to connect those points carefully so we can see that nice intersection point, and that is going to be the y. And if we look to where they intersect, it is at 2, -1. So our solution is 2, -1. And again, you can check that solution if you want to find out, make sure it's true. So that is how we graph systems of equations.